All right, let's finish up these really important concepts. Okay, so what I was saying about the about finding a confidence interval for the variances of a population is that it's based upon the sampling distribution for the sample variances, and the sample variances are distributed with this distribution called a chi-squared distribution with n minus 1 degrees of freedom. Now this is a non-symmetric interval, and so when we go to find those critical values, we still put our 1 minus alpha here in the middle, but the chi-squared left value over here and the chi-squared right value on this side are no longer going to be symmetric to some middle point in here, because this is not a symmetric distribution. It starts at 0 here and just increases on up. So we actually have to use a table to look up two actual values. Now, we do usually use a table, although there are some programs out there that will give us chi-squared values. I find them to be highly inaccurate and unreliable, and therefore I'm not so apt to use a calculator as a secondary option here. So these chi-squared tables, what you need to realize is most of them are based not on a left tail but on a right tail value. So this chi-squared right value will have n minus 1 degrees of freedom, and then it'll have our area over here in this tail. And then the chi-squared left value, it will have n minus 1 degrees of freedom, but it will be based upon not the area over there, but this area this way, which ends up being 1 minus the alpha over 2, which can be kind of confusing because we've never done anything quite like that. So that's where we get those chi-squared values. And when we see the confidence interval for a variance, you see the right value is on the left side and the left value is on the right side. Well, the reason for that is because the chi-squared random variable, it looks like an n minus 1 multiplied by s squared and divided by sigma squared. And so what happens is we end up getting a value in this thing. We have a chi-squared right over here, and it has a chi-squared left over here. And when we solve this thing to leave this chi-squared in the middle as we go through the algebraic manipulation of that, what happens is we end up flip-flopping these inequalities. So when we solve this one across, we end up getting the right one to flip across here, because when you take the reciprocals, it flips everything around. And that is what we have to understand in why the left and the right are backwards. So it has just a basic math explanation. So this is our interval if we want a estimate of the variance. And by the way, it is possible to get an estimate of the standard deviation of the population. You just take the roots of all three of them. But there is no way to look at the standard deviation directly. You must go through the variances just like we did when we were finding a standard deviation for a sample. You gotta go through the variances. All right, now the very, very last thing that I want to talk about is I want to talk about our little bit of hypothesis testing that we're going to be talking about in chapter, or on this test. So hypothesis testing. What do I want you to know for hypothesis testing? Well, number one, I want you to be able to write me hypotheses. I want you to be able to write a null hypothesis and an alternative hypothesis, an H sub 1 or H sub A, whichever one you want to use. I want you to know that the H sub 1, the H sub A, is usually based upon your claim. But this one must contain equality. So I want you to be able to do that. And I gave my classes at Foothill in particular some problems where you were just giving me hypotheses, and we talked about a whole lot about setting up the hypotheses in introducing this entire chapter. Then after that, I want you to be able to do a traditional only test at this point in time. I'm not going to ask you about p-values or confidence interval tests, none of that, just a traditional test. So in a traditional test, I want you to be able to find the critical value, right? So find that critical value. Well, critical value, that, remember, goes back to finding the value under the distribution with some amount in a tail. From your alternative hypothesis, you're going to tell me which tail you're in, upper tail, lower tail, or is it a two-tail test? And if it's a one-tail test, all your alpha, right, this is 1 minus alpha, your confidence level, and this is your significance level. All your significance level, all your alpha goes in one tail if it's an upper tail or a lower tail, a one-tail test. And if it's a two-tail test, right, one tail, we have less than or greater than for a one tail. And a two tail is a not equal to. So these one tail tests, we have alpha all in one tail, upper or lower. And this one, where we have a not equal, that's a two tail test. Critical values look just like a confidence interval when we have a two-tail test, but they're always going to be based upon the same ideas that we talked about with an inverse normal distribution. So this confidence or finding critical values is just like what I said before. It's finding the inverse distribution. So I could scroll right way back here. Let me not do it page by page. Let's do it this way. I go all the way back here to know an inverse distribution, a value from the distribution based upon a probability. That's what confidence critical values are. And so we're going to be finding our probability. This is just an alpha, right? That's our alpha. And if it's in two tails, it's alpha over 2, which that's how we find critical values. So that's what we want to be able to do. And we want to be able to do that in order to find our critical value. And our critical values are important to us in hypothesis testing, because in hypothesis testing, that is where we're going to make our decision. So, all right. So that's the second thing in a hypothesis test I'll want you to be able to do. Then the next thing I'll want you to be able to do is I'll want you to be able to come up with your test statistic. Well, again, a test statistic is just some more of that stuff that I asked you to know earlier. I want you to be able to standardize, right? A test statistic is a Z or a T. And if this is for means, right, they look like the following. It's a Z, so I've got my X bar value, minus my mean under the null hypothesis, that's why a subscript of 0, and then this is the standard deviation that's told to us, divided by the square root of the sample size. If it's a T, then I don't know the standard deviation of the population, so that's all that changes about this test statistic. We still, the mu underneath the null hypothesis, and then this instead of sigma is S divided by the square root of n, and that's our test statistic. If we're looking at a proportion, it's still a Z, right, because proportions, p-hats, are distributed with a normal distribution, so with a proportion, it'll look like an X bar. No, it will not look like an X bar. No, it will not look like an X bar. That's the deal. It doesn't look like that, right? No, it will look like, and let's make this one in a different color so we really see how different it is. It will look like our p-hat minus our p naught, the proportion under the null hypothesis, divided by the standard error. And the standard error here will look like p naught, null hypothesis p, q naught, which is based upon null hypothesis p, divided by the square root of n. So this whole thing is under one radical, right? P naught times q naught divided by n, take the radical of that whole thing. That's our standard error. Remember, guys, that a q naught is just equal to 1 minus p naught. And again, p naught, that is a subscript of 0, meaning that it refers to the null hypothesis. We call that naught. Okay, so those are our test statistics. Now, the last thing that I want you to be able to do is to make a decision, right? And your decision is whether your test statistic lies in a rejection region. So you do this. test statistic in rejection region? If the answer is yes, then we reject HO and we accept HA or H sub 1, whichever one you want to call it. And if it doesn't, then we fail to reject the null hypothesis. Period, end of sentence. That's the only thing that you decide. You must tell me one of these two conclusions. If you tell me anything else, I'm probably not going to give you full credit. Those are the two acceptable ones. And finally, what I want you to be able to do is I want you to be able to make a conclusion. And remember the conclusions, I want 3 particular parts to that. I want your confidence level or your significance level. I want your enough evidence, and this and enough or not enough evidence, and that refers back to whether you can reject or not. If you have enough, right, then you reject it. So this indicates enough evidence, and this one is not enough evidence. And then the final thing that I want you to put is the original claim. And the original claim, usually you have to go back to the wording of the original problem and find out what that claim is. It is the claim under the HA, right, under your alternative hypothesis. And that's what you need to know for hypothesis testing. Now, more than likely, this test, probably the most I would give you would be for a mean. The proportions, I know people have a little bit of difficulties with those, and I don't want to go for difficult. I really want to see if you know the basics. So the most basic hypothesis test is for testing a mean when the variance of the population is known, or when the standard deviation of the population is known. And so usually that's what I end up giving you. And I pretty much just follow along this path. This is what I want you to do. I want you to, number 1, give me the null and the alternative hypothesis. Draw a little diagram. Put your rejection region. Put the critical value. Once you've done that, find your test statistic. Once you've found the test statistic, put it back on the diagram, right? So you have to say, okay, here's my critical value here, and here's my test statistic over here, or if I fail to reject, then my test statistic over here, possibly, right? You put it where it belongs. If it's in the rejection region, then you have enough evidence to reject the null and accept the alternative. If it's not in the rejection region, right, if it's not in this region over here, if it's in the main body, then we fail to reject. And then finally, write your conclusion. Okay, those are the things that I'll be looking for you to know. And that's it. I really hope that this helps. I still encourage you to go read through all of the fine level details on the outline for this test that I've given you. But this is a verbal, this is kind of a big, bold, this is what I want you to know. So good luck, guys, and hopefully you'll be well prepared for this test, or feel well prepared for this test. That's my goal here.